my name's Chris. You're looking at my Minitech mini mill, cutting a job, a real paying job. And I think it's quite important I do this video, since the majority of the videos out there show these mills cutting air, which I don't think gives a true indication of how the mills operate, what real life scenarios are, and the amount of noise they make and the amount of mess they make. For the purposes of this example, I have a little model being cut. I'll try and clean it up a little if I can. I don't recommend doing this normally. You run the risk of breaking your cutter. You may be able to see a little bit of the model coming out over there. What this is a box, and it's catch for a 3-strand diamond bracelet, and further on in the wax, in about probably half an hour or so, it's the rest of the female half will come out. Alright, a little bit more about this job. The cutter you're looking at in the spindle over there is a 10 degree 5-thal or a 0.127mm cutter. It's a pyramid cutter, has 3 sides, and it's travelling at, well, it's programmed to travel at 600mm a minute, but like I said, for the example here, I want to get this mill really as noisy as I possibly can, so I've cranked it up by 50% to 900mm a minute, and this is pretty much as loud as it's ever going to get, unless you get into cutting steel, of course. That's a whole new ball game, steel or aluminium. A large, probably I suppose, percentage of the reason why this is nice and quiet is it's a very durable, really heavy aluminium frame with there's almost no vibration travelling through it. I happen to have mine bolted down to the table. I think the majority of people don't bother, but probably that's another factor keeping mine nice and quiet. I also own another mill, a Roland, which by comparison sounds like a running angle grinder. Okay, so to show you a little bit about the controller. The controller is just a standard PC with a 17-inch LCD screen, about 150 bucks off eBay. That little guy over there is the spindle control. It's running at 13,000 RPM at the moment. It can run up to 30,000 RPM, but probably all I'd end up with is a big block of melted goo, unless I've got a liquid coolant in there, and the majority of the guys using these mills prefer not to use the liquid coolant. I don't know how true or accurate this statement is, but from what I glean, the majority of guys are cutting dry, as it were. This is the controller screen. Those are all the axes moving, instructions being sent out to the mill at the moment, and it gives you a real live-time view of what's happening in the mill. This is the line of code that we're on, and that's the actual code window scrolling up and down. And if all of this is Greek to you, don't worry, it's Greek to me too. You don't need to know anything about this. All you need to know how to do is find your X and click that button. You can make this as complicated as you like. It doesn't need to be. Really simple to use. Over here is our feed rate. Like you can see, the programmed feed rate was 600mm a minute. I've clocked it up to 900mm a minute, and that's the actual velocity being achieved over the workpiece. Of course, the bit can only travel as fast in X and Y as what the Z movements will allow it to as well. I think probably that's pretty much about it. So the primary purpose behind this whole video was for me to talk to you a little bit about this mill while the mill is running basically full toss. So through watching this video you can get an idea in a real world scenario of whether this thing is suitable for your work environment, how close you can have it to your clients. I find mine that quiet. My living room is probably about 5 meters from here, that I've had to install a remote camera so that from my lounge room I can actually hear it. I'll go inside in just a second and show you my monitoring station, and then also just switch off my computer's sound so that you can get an idea. Alright, the next you'll see from me is in my lounge room. Okay, my lounge room. As you can tell, that sounds pretty loud from inside my lounge room. This is the video feed from the little camera I was showing you outside. While it appears that you can still hear a lot of noise, I'm about to, well, that's a little dark in there, I'm about to kill the sound of my speakers. Alright, The rustling you can hear in the background is my kids sitting in the lounge room. Other than that, literally right through that wall, on the other side of that wall is the mill. So you can understand why I need a cam to be able to tell whether my mill is actually still running or not. I think this proves as much of the point as I need to. This Chris, over and out. Have a good one. Oh, whoops, hang on. I promised you I'd show you the job. So this is Rhino, my design program, and what's on in the mill at the moment, the part you saw would be exposing this area here. So that mill's travelling back and forward at 900 millimeters a minute, and it's busy. At the moment it's about probably in this region here. Within the next sort of 30 to 40 minutes it'll be up here. The mill will rotate this job around and finish cutting it. When this is done, like I said, it's going to be a catch and clasp for a 3-strand diamond bracelet. Nice job. I'll try and grab some video of the finished piece if I can. Well, come through to check that everything's still going well. Sort of a redundant thing that I do because I've not yet had this machine do any peculiar nonsense to me, but quite a few people will recommend that you never leave a running mill alone. I tend to disagree to an extent, because why would you have bought a mill if you're going to sit there watching it all day? But for official purposes, the recommendation is to watch your mill. I tend to come in every 20 minutes or 30 minutes, just make sure nothing has gone haywire, make sure everything is still going alright. You can see, I'm going to try and blow that up. This is where all the mess comes from milling. You can sort of see that model starting to come out of the wax there. I'll try and be for when the rotation happens, and grab a little bit of that on tape too. Catch you later. Okay, thought I'd come out and check on it again. It's been going for a little bit now. As you can tell by the beautiful sheen on those surfaces. Great cut. There's one more set of tubes to cut up the top here. So probably I'm just making another 20 minutes or so, then it'll turn over. Total running time so far has been 1 hour 43, so I'm guessing about 2 hours a side. The second side obviously will take then 2 hours as well. So yeah, not too much longer and this will be done. Looking good so far, I'm happy with it. Try and catch a bit of an angle on that so you can see the finish. It's good, real good, and that really is what you're after, isn't it? I can grab some more video in a second. Okay, this should be ready to flip around any second now. It's finished the whole top pass. So what it'll do is the spindle will pick up, the A-axis here will turn the whole piece around 180 degrees, and the spindle will come down and start cutting the back end of it. You can tell that when Z, the up and down, is not got too much work to do, you can maintain a higher velocity. He cut at almost 900 there. Obviously then when it's in the middle of a job and there's a lot of up and down action going on, then probably velocity will be averaging out at maybe 400 or 500 millimeters a minute. Anyway, so let's watch it flip, and then I'm going to publish the tape. I'll put a couple of pictures of the wax on my website when it's done, but it's starting to get a little late here. It is 7:30 in the evening, and legally I have to supposed to turn this off at 8 o'clock in the evening, but what I'm going to do is just going to shut everything down nice and quietly in the garage here and just leave the mill running silently and hope I don't pick up too much flack from my neighbour. Luckily it's a really quiet mill, hey? Let's see, shouldn't have too much further to go before the flip happens. A little bit about the step over. The step over essentially is, as this is cutting axially back and forward, how far do I want it to move when it cuts each stripe. So my step over in this case is 25 microns, 0.025 millimeters. Many guys cut with higher step overs, 30 micron or even 50 micron. I tend to use the smaller step overs because I'm lazy. I don't want to be filing the stuff to death to get lines out of it and steps out of it. And if you're going to have huge step overs and lines, you might as well just buy a grower. And if you're going to put yourself through all that extra work, what was the point in buying a high precision piece of equipment to use it at gross numbers? Some work where there's not too much detail, you can use bigger cutters with bigger step overs and achieve the same finish. It all sort of comes part and parcel of understanding your mill. There is a learning curve, as there is with all equipment. With these mills, it's a lot lower. Being able to trust your mill to, first of all, finish a job accurately, and second of all, actually make an accurate rotation where it will turn 180 degrees, not 179 point something degrees, or not 180 point something degrees, but actually 180 degrees, so that your piece doesn't come out skewed or have any issues. You'd assume that that's a given with milling machines. Don't be mistaken into believing that. It's not. Not too many machines around doing it right. I'm not saying anything, I'm just pointing at it. Okay, so flip over already. What else can I tell you while I'm waiting for that to happen? Essentially Mac, the software that runs the controller, all the working mechanisms, all the electronics for the mill or inside that little box over there, and they're being controlled by the software over here. Mac, I think, is $199. It obviously ships with these mills, but at $199, I think it's a fantastic piece of software. The amount of control it gives me over every stage of my production with the mill is out of this world. You're standing looking at the default screen now, which is a screen that is shipped with, but I've made my own screens. I've added customized toolpaths, hub cutting routines, many different things that I've already managed to add to it as it is. So it's highly customizable. You didn't just buy it and you lumped and you're stuck with it. And its forum is populous by some of the smartest guys I've ever met. At this point, I'd like to say as well that probably if you're going to look at getting into this, you're going to want to be looking to join a few forums, read up on it. Probably if you've watched this video through my website, you'll see links to the 3D CAD Jewelry forum. The Mac forum is probably not a bad place to go. CNC Zone is also a very good forum. I frequent quite a few of those forums under a few different names. Contact me through the web and we can have a look at it. Alright, so this basically is just going to rotate that around 180 degrees, and then it's going to start cutting the second side. Now for the initial plunge, I don't like to be running at 900 mil a minute, so what I'm going to do is I'm just going to hit 100%, take it back to 600, let the initial plunge get over and done with, let it go down, and what I like to do is just let it cut one pass, even though there's no load on the cut of the tip of there, on the tip of the cutter there, because it's already in the wax. What I like to do is make two passes and then I'll crank it back up again. Alright, so let's crank her back up. 660, 720, 780, 840, 900. Oh hell, let's live large. Let's go, 1020. And if I break a cutter, I'll be really embarrassed, but I've got a feeling I won't. And that over there is the Minitech doing what it has to, saving you the trouble of having to make nonsense like this. I'm going to go sit back and let this finish. I'll try, if I'm still up and about, I'll try and grab some video of the finished product. Regards. Okay, I'm going to close up here for the evening and let this finish. I've cranked that Betty up to 1140 millimeters a minute, and seems to be running fine. I can't blow that. Move this dust out the way. Alright, so you can tell that I'm not getting the usual surface areas or anything like that. The surface finish still looks good. Well, everything's running well. So I'm going to post this tape now, and I'll post some images of this wax when it's done cutting. Have a good one. Yeah, that's pretty fast. Notice no vibration. Beautiful, thing of beauty. Now, hopefully I'm getting in trouble for leaving my mill running in the evening. Beautiful to watch that doing it. I love my mill. Jack, you build a beauty. Some fantastic